because today we're going to be looking at a different kind of differentiation. Now the principle we're going to be working with today is differentiation based on first principle, right? Differentiation by first principle. Now this one happens to be very long, and maybe some think of it as the most difficult method of differentiation. But today on this channel we're going to simplify it as much as we can. So our advice is pay much concentration, pay much attention as the video goes on. So let's get to it. Alright, so for the purpose of today's video, we're going to be having these three examples, 1, 2, 3, to differentiate using first principle. We're going to differentiate this first function, y equals 3x squared, and the rest using first principle. Alright, but before we go into the examples, this is what's going to happen. I'm going to differentiate these functions using the general differential method we all know, right? And then keep our answers aside so we can compare them with the answers we get when differentiating first principle. So for this first example now, if we are to differentiate this first example, y equals to 3x squared, what are we going to get as dy dx? What are we going to get as dy dx? We're going to multiply the power, which happens to be 2, right, with the coefficient of x. That's 2 times 3, happens to be 6, right? Then you have x raised to power 2 minus 1. You reduce the power of x by 1, right? And if you reduce 2 by 1, you're going to have 1 here. So our differential is going to be 6x, right? Now let's look at the differential of the second function. Now dy dx for the second function is going to be this. The coefficient of x here happens to be 2, right? And the power also happens to be 2. So 2 times 2 is going to give us 4, right? So we'll have 4x raised to power. If you reduce this power, which is 2 by 1, you're going to have 1 as well, right? So we differentiated this first term. Let's differentiate the second term. So we have plus. What's the differential of x? You know the coefficient of x here is 1. The power is also 1. So 1 times 1 is going to give us 1, right? And if we reduce the power of x, which is already 1, we reduce it by 1, we're going to have 0, right? So this will be x raised by 0, which happens to be this way. So the differential of the second function is going to be 4x plus 1, right? The differential of this function here is going to be 4x plus 1. Now let's differentiate the third function and just keep the answer aside. Now dy dx for the third function is going to be this. The coefficient of x happens to be 1, right? And the power of x is 3. So 3 times 1 is going to be 3. And we're going to have x raised power 3 minus 1. We're always reducing the power by 1, right? So 3 minus 1 is going to be 2. So we're having 3x squared. How about this 5 we have here? Negative 5. Now we all know that whenever you differentiate a constant, you get 0, right? Be it negative or positive. So if you differentiate minus 5, you're going to have 0. Alright, so this is like the formula we're going to be using during the course of this topic, first principle differentiation, right? Now this is how you find dy dx. Now you're all aware that dy dx means the same thing as changing y over changing x, right? Changing y over changing x. But this is the term we're going to be working with mainly here. So to find dy dx or changing y over changing x, this is what you do. You're going to take the limits. I'm going to explain limits for us now, but listen. We're going to take the limits of this expression here as changing x approaches 0, right? To find dy dx or to find change y over changing x, which actually means the same thing, we're going to take the limits of this expression here as changing x approaches 0. You understand? Now before we proceed to solving these examples using this formula, let me explain what limits actually mean, right? For example, if you have a function like this, f of x equal to x minus 1 over x squared minus 1, and you are asked to find the limits of this function as x approaches 0, right? Find the limits of this expression x minus 1 over x squared minus 1. Find the limit of this expression as x approaches 0. Now this is what you're going to do. You're not going to just go further into substituting the value of x as 0, right? Substitute 0 here or substitute 0 here and then solving to get the final answer. This is what you're going to do. You're going to check if it is possible to simplify the function further before you start substituting for the value here. The value could be 1, it could be 2, it could be whatever the value is, but let's work with 0. right? Now this is what you do. Let's see if we can simplify. If we can't simplify further, then you just substitute x to be 0, right? Same goes for this. If you get to this function when differentiating and you can't simplify further, just substitute the value for changing x as 0, right? So let's see if we can simplify further here. Now this is x minus 1, right? Over, this is x squared minus, you see 1 here is actually the same thing as 1 squared, right? You know 1 times 1 is still 1. So now I have difference of 2 squared at the denominator here, right? I have difference of 2 squared. So this is going, I'm going to expand this difference of 2 squared as x minus 1, x plus 1, right? That's the expand, this is the expansion for difference of 2 squared. X squared minus 1 squared is the same thing as x minus 1, x plus 1. Now since I've made this expansion, x minus 1 can actually be cancelled by x minus 1, right? Leaving us with 1 over x plus 1. Now when we arrive at this point, I believe there is no further simplification here, right? So we can then proceed to substitute the value of x as 0. So the final answer, that is the limit of this function as x approaches 0 is going to be this 1 over, this is 0, right? We are now substituting x to be 0. This is 0 plus 1, right? We are now substituting x as 0, so there is no further simplification. This x is now 0, so 0 plus 1, that's still 1. So we have 1 over 1, right? And 1 over 1, that is 1. So the limiting value of this function as x approaches 0 is actually 1. Alright? Now assuming you understand what finding limits of function actually mean, let's now go further. Let's proceed with differentiating these functions using first principle. Alright, so let's take the first example. Y equal to 3x squared, right? Y equal to 3x squared. We're going to differentiate this using first principle. Now from the formula we have, you see that we are going to take the limit of this expression. What is actually this expression? F of x plus change in x minus f of x. Now, this f of x here means a function of x, right? You see this y here is actually a function of x. I believe we've explained something like this before on this channel. This y here is a function of x because to get the value of y, you have to work with x, right? So let me rewrite this as f of x. Okay, I'm not going to rewrite it, but just know that this y is actually a function of x, right? And this is the first function of x we have here. Now, how do we get f of x plus change in x? You know, differentiation is all about change. Now, if you check these values, they are not actually, the value for x is a variable, right? It's not a constant. It's going to be changing, right? It's not a constant. So let's see. Even this y here is also a variable. We don't know the exact value of this y, but we know it can change from value to value. Now let's say this y actually changed value. Let's say it increased, right? It increased. It means it's going to add a new value, and that value this y is going to add, we're going to call it change in y, right? If this x here also increased, you know it's also a variable. We're going to have x plus change in x, right? That's the change that was added. It could be a negative change if x decreased, or a positive change if x increased, right? So we still have our square here. Now we have two expressions here. The first one, which is f of x, you get the point. The first one is just f of x, but the second one is f of x plus change in x. This is not ordinary x that you're seeing here. It's actually x plus change in x, right? So what is this expression trying to say we should do? What is it telling us to do here? It's saying we should subtract this f of x from f of x plus change in x, right? So we're going to say this minus this, right? You can see this minus this. Do you get the point? So let's subtract this from this. This minus this. All right, so if I say, okay, let's call this equation 1, if you know, for better understanding, and call this equation 2. So what we're going to do there is equation 2 minus equation 1, right? This is what we're going to do right now. So let's do that. Now this equation 2 here, we have y plus change in y, right? That's equation 2. If you subtract the corresponding value from equation 1, we have minus y, right? That's for the left hand side. Now for the right hand side, on equation 2, we have 3x plus change in x squared. right? We have 3x plus change in x squared minus, what do we have on equation 1? Minus just 3x squared, right? You understand what we did? We said this minus this and this minus this, the left and right hand side. Now here we have y plus change in y minus y. Here we have 3x plus change in x squared minus 3x. That's what we did. So let's carry out this subtraction. Now you have y plus change in y minus y. This y here is going to cancel this y, right? Since y minus y is gone, leaving us with change in y. Do you get the point? Equal to, how do we open this bracket? We can't go straight to opening this bracket by saying 3 times x, 3 times this, when we have a power of 2 here to work with, right? So let's work with that power of 2. We're going to have x plus change in x, right? Multiply another x plus change in x. Since we have square, right, this is going to multiply itself twice. If we were something like raised to power 3, there will be another term here to multiply with, right? Then we have minus this, that's 3x squared, right? So let's open this bracket and see if we can make progress. Change in y is going to be equal to 3. Let's open these two brackets. X times x, that's x squared, right? Now x times change in x, that's x change in x, right? I mean x times change in x, that's x change in x. Now we've used this to multiply this and this. Let's use this to multiply this and this. All right, so change in x times x, that's x change in x, right? X times change in x, that's x change in x. Then change in x times change in x, that's change in x squared, right? Now we have opened this bracket. Now we have minus 3 here, minus 3x squared, right? Now we have a bigger bracket open with this 3, right? So change in y is going to be equal to 3 times x squared, that's 3x squared, right? 3 times x squared, 3x squared, then 3 times x change in x. Okay, before we go to that, can you see that we have x change in x and we have another x change in x? That is in total, how many change in x do we have? 2, right? So we're going to have 2x change in x here because we have 1 here, 1 here. So in total, that's 2x change in x. So now if we open this bracket with 3, it's going to be 3 times 2 since we have 2 of it. 3 times 2, that's 6 of it now, right? You can understand? 6 of x change in x plus finally 3 times change in x squared. That's 3 change in x squared, right? We have opened this bracket. Then here we have minus 3x squared. Minus 3x squared. We are still trying to carry out the subtraction of f of x plus change in x minus f of x. So let's see what can happen here. Change in y is going to be equal to, okay, this is 3x squared, right? And this here is minus 3x squared. So this 3x squared here can cancel this 3x squared. So they are going to subtract each other out, right? Leaving us with 6x change in x plus 3x, change in x squared, right? When we subtract that, we're left with 6x change in x plus 3x, plus 3 change in x squared, right? Now we have carried out this subtraction from the formula here, the formula we use for first principle, right? This subtraction here, we have carried it out, and this is what we got. This is what we got, right? This is what we got. Now, from the same formula, we are asked to divide it with change in x. Whatever you get from your subtraction, divide it with change in x, right? So this is what we are going to do. I'm going to divide both sides with change in x, right? So change in y over change in x. I'm dividing this left side and the right side with change in x is going to be equal to 6x change in x plus 3 change in x squared divided with change in x as well, right? I'm dividing both sides now with change in x. Now, to proceed further, we have change in x in this term and we also have change in x in this term, right? So we can actually factor out change in x. So change in x cancels out change in x, right? So let's carry out that factorization. Alright, so factorizing this, we're going to have change in x, which we have in both terms, right? We're factoring it out. You're going to be left with 6x if you bring out change in x from 6 change in x, right? If you bring out change in x, you'll be left with 6x, you understand? How about if you bring out change in x from this? You'll be left with 3 change in x, right? Why? How is that? This is 3
change in x squared. That's to say that there are like two change in x here, right? If you bring out one of them, the other one will be left behind, right? That's why we have three change in x. If you bring out one of the change in x, right? All over change in x. All over change in x, right? So this change in x is going to cancel this change in x, leaving us with this change in y over change in x is equal to 6x plus 3 change in x. Now remember there is no further simplification here, and the answer we got when using the general method of differentiation, we got dy dx to be 6x, right? So what's the difference? What's making the difference here? It's that the presence of that change in x. So remember, we have to take the limit of this function as change in x approaches 0. You remember that, right? So since we have got to this point, let's substitute change in x as 0. Since that you can see there is no further simplification here. So change in y over change in x is going to be equal to 6x plus 3 times what? 0. You understand? So finally we're going to have 6x plus 3 times 0. That's 0, right? So we're just left to 6x. So our answer for change in y over change in x is going to be 6x, which is the same thing as what we got using the general method. Now you can see that yes, this first principle is actually wrong. But let's just know it, right? Let's just